Today's lesson 10.9, circumference and arc length, will be a quick review of what we've actually talked about earlier in the chapter. Just two quick definitions and formulas before we get into two examples. The first one is circumference. Again, you should know what a circumference is based previous lessons. Circumference is just the distance around the center of the circle and the total length of that. We can calculate circumference by pi times diameter. And what an arc length is if we have an angle from the center, what we do is we can take theta and we can take it over 360 and multiply it by the circumference. And what that does is it gives us a portion of the length of the circumference that corresponds to this angle in here. So it's a portion again of the circumference. First example that we'll take a look at is from page 502, number 7. And it says, find the length of the fencing needed to surround the racetrack. And we'll actually be calculating to the nearest tenth. Now, as you can see, this is what the racetrack looks like. This right here is actually a semicircle, as is this. There's a better diagram in your book. Since it's two semicircles with the exact same diameter, because we know that that's a rectangle in there, if I can get it out, we'll calculate the circumference of that. So it would be 12 pi, because that's one full circle, and because this is a rectangle, this and this is congruent, so we would be adding 100 to that. And if we calculate that in our calculator, this actually becomes 37.7 plus 100, which gives us 137.7. And the units on this is actually meters. And our last example, again from page 503, number 16. A circular garbage can is wedged into a rectangular corner. The can has a diameter of 48 centimeters. Find the distance from the corner point to the can, PA, and A is actually right here. And then part B asks us to find the distance from the corner point to the point of contact of the can with the wall. So we'll start with, since we know that the diameter is 48 centimeters, we know that the radius will be 24. So we'll connect the radius to points B and point C. Now, because we know it's a perfect circle and because we know it's a rectangular corner, we know that this is 90 degrees. And because we know that the circle is consistent with radius, we know that if we extend this line, it will be a bisector. So each of these angles will be 45 degrees. And because PC and PB, again, are from a rectangular corner, that means that they're going to be tangent to the radius. And since this is 45 and that's 90, this will also have to be 45 degrees, meaning that this side and this side are congruent. So this will have to be 24. And if we look at this rectangle in here, we have 45, 45, 90, which means that based on the proportions, PX would actually have to be 24 square root of 2 for that full length. But we're actually trying to find PA, which is this length in here. And since we know that the radius is 24, this area in here, PA, is calculated by taking the full length, 24 square root of 2, and subtracting the radius, which is 24. So that's part A. Part B is actually calculated a little bit quicker or easier. because we know that PB is tangent, that is 45 again, or 90 again, right here. And this is 45, and that's 45. This is congruent to that. So PB will have to also be 24. That would be centimeters. Now, a hint for those of you that actually watch and listen to the full video. On your test, you can expect one of the word problems from this night's homework on the test. So I would make sure you ask questions and take good notes and really review those before the test.